Hello and welcome to Algebra 1, Simple and Compound Interest. In this video, we are going to solve real-world problems involving simple interest and compound interest. So we're going to be writing equations that represent simple and compound interest scenarios and solve problems relating to those scenarios. We're also going to get into exponential growth and decay functions as well. In this video, we are going to be covering these Florida B.E.S.T standards for mathematics. And so let's go ahead and jump right in. So on our EOC reference sheet, we have this at the bottom. And so it gives us the formulas, but we still have to know what they mean and how to work with them. So what's in the yellow box is on the reference sheet. When you first get your reference sheet, I strongly recommend that you make some notes on there. And so right when you get your reference sheet, let's go ahead and mark that this is our starting point. So your starting point is always going to be that number outside of the parentheses. And that goes the same for this one. That's our starting point. And it doesn't matter whether it's compound interest or simple interest. Now for the rate. You want to make sure that you write as a decimal. It's usually going to be a percent in the scenario or inside the word problem. And if you're not sure how to write a percent as a decimal, just remember that percent, per means divide, and then cent means 100. There's 100 cents in a dollar, there's 100 years in a century, so divide by 100. So if you're not sure how to move the decimal twice and in what direction, you can always remember that percent means divide by 100. And so that goes the same for rate here as well. T is going to refer to the number of years. And then with compound interest, that's where we start talking about how many times are we compounding the interest in a year. And so that's going to be the number of periods in a year. So annually, that's just once a year. Semi-annually means 2 times in a year, so every 6 months. Quarterly, we remember that means 4. And then monthly, you should know that there's 12 months in a year. And then for weeks and days, that's actually on your reference sheet as well. So if you get caught up with that one, you can always check. That is in one of the conversions up at the top. So there's 52 weeks in a year, and then there's 365 days in a year. Whether it's a leap year, anything like that, none of that matters. Same thing with monthly. They're not going to change how much they are compounding interest, whether there's 28, 29, 30, or 31 days in the month. So just kind of keep that in mind. And in this video, we are also going to talk about exponential growth and decay formulas and equations, and that actually goes with what's on our reference sheet. So we can tell that just by looking at these formulas that this is going to be linear. Okay, and then this one gives it away that it's exponential because we have this exponent up here. And we can actually use our reference sheet to kind of trigger our memory about exponential functions in general. So this might be something you want to add to your reference sheet just when it comes to exponential functions in general. So with this one, we also have exponential functions where it's y equals, and then it's often used as an a, and then we have 1 plus or minus, and then the rate, and then we have the time stamp up here in the corner as our exponent. So really just notice that it's almost the exact same formula without the ends, or the number of times that something's being compounded in a year. And then if it's growth, it's going to be a positive rate. And then if it's decay, it's going to be a negative rate, but you're going to treat it exactly how you would for this compound interest. So this compound interest formula really kind of gives you a cheat sheet and a reminder of how to do exponential functions in general. So we'll get to those in a minute, and I wanted to include that in this video just because they are very, very similar in how we would go about finding them. Okay. All right, so let's go ahead and get started. So our first problem here says it's a simple interest problem, and it says James deposited $3,400 into a savings account that has an annual simple interest rate of 0.2%. Find the amount in the savings account after 5 years. So how much is in the account is going to be A. And then we remember that P is going to be our starting point. And so he started out with $3,400 in the account. Now, the reason why there's a 1 there is because that he's still going to keep that 3,400. So we still want to multiply that 3,400 by 1, and then we're adding on that rate times the time. So that's going to be 1 plus, and then remember, when we talk about that rate, we want to put 0.2% as a decimal, and if you're not sure, we can always put it back into our calculator. So we're going to clear our calculator, we're going to put 0.2, and then percent means divide by 100. And then press equals, and it gives us 0.002. So if you're not sure, you can always use your calculator as a backup. Or you should know that if we take the decimal to the left 2 times and then we fill this in, it would be 0.002. So we have 0.002, and it's going to be that 0.2% for 5 years. So times 5. And then we can go ahead and put that whole thing in our calculator. So you could do 3,400 times, and then parentheses 1 plus 0.002 times 5, close parentheses. Or if you feel more comfortable, put this in your calculator first. Either way, you're still going to get the same answer, and you should get $3,434. And then you can put your $ here. When you guys are doing exponential growth and decay functions, they might actually ask you, even if you're doing simple interest, give us an equivalent expression. And so you might see something like this one come up. But you may also see where we type this into our calculator. So if they ask you for an equivalent expression, you might see something like 3,400, and then times that 1 plus 0.002 times 5, which gives us 1.01. And so you might see it like this, where they're asking you for an equivalent expression. Both of these would give you the same answer. So just kind of keep that in mind if they are asking you for different ways of writing the same equation. All right, let's try another one. So this one says Michael opened a savings account with $4,500 that earns 0.6% simple interest annually. And so a lot of times they'll tell you whether it's simple interest or not. But if it doesn't, you can normally assume that it's simple interest. Compound interest is normally going to have the word compounded in the scenario. So they will kind of give you hints for those. And so with this one, It says, after how many years will the balance of the account be 4,635? So now the balance in the account is here. So 4,635 is now what's in the account. He's starting out with 4,500. And then multiplied by that 1 plus our rate. And don't forget that R is going to be 0.6%, but we have to write it as a decimal, so that's going to be 0.006. If you're not sure, type it in your calculator. 0.6% divided by 100 gives us that 0.006. And then T, or how many years, is what we're trying to find. So that's going to be times T. So if they're asking you for an equation, they might ask you for something that looks like this. And then from here, what we would do is we could distribute. And so we get 4,635 equals 4,500. So don't forget, we're still starting with that 4,500. We want to keep it. That's why we multiply it by the 1. And then plus, and then what you're going to do is you're going to take that 0.006 and multiply it by your 4,500. And that gives us 27T. And then from here, we're just going to work to get T by itself. So I'm going to subtract 4,500 from both sides, and that gives me 135 equals 27T. And then from here, I'm going to divide both sides by 27, so I can go back to my calculator. And as you're working on your EOC, I highly recommend that even if you could do a lot of these calculations by hand, that you are using your calculator and putting it to work, because you are going to be extremely mentally fatigued the longer you work on these tests. And so let the calculator do a lot of that heavy lifting, especially when it comes to basic math facts. Plus, you want to use your calculator so you're not making any silly mistakes. So even if you know how to do it, even if you can do it by hand, use that calculator. I can't stress that enough. And so for this one, it's going to be T equals 5. So it's going to be after 5 years. That's going to be our answer. Okay. And so just kind of keep in mind that as you are working on these, this right here, so we started out with 4,500, right? And then in the account, it said we had $4,635. And then when we subtracted that initial amount that we started out with, we ended up with 135. And what that means is that that was $135 of interest. So we made, or Michael in this case, Michael made $135 in interest. And so if they were asking about interest, that's always going to be, it's going to be A minus P. So whatever's in the account minus what you started with, and that's going to give you your interest. So just kind of keep that in mind as you're working on problems like this. All right, let's do another simple interest problem. It says Angelica loans Oliver $1,500. Oliver agrees to pay Angelica an extra $225 when he repays the loan in 1 year. What is the annual simple interest of the loan? So we're going to kind of think about what he owes as that amount at the end. So at the end, he's going to owe the $1,500 plus the interest that he's paying back. So plus that $225, And so that gives us 1725. And so just like how I said that interest is A minus P, well, that means that P plus the interest is going to give us A. So we have 1725, and then we started out with 1500 plus 1 plus R, which we don't know what it is because it says what is the simple interest rate, times the time. And remember, for this, time is years, and this is after 1 year, so times 1, which is just going to be R. And then we've got 1725 equals 1500 if we take this, right? And then plus 1500 R. And then when we go back and subtract this, it's going to be even clearer when we see it written like this. We're saying how long did it take him to pay back, or what percentage of his original amount, right? And so to find out the percentage of the original amount, we're just going to divide by the original amount. So we're taking the interest and we're dividing it by his original amount. And then so I'm going to lean back on my calculator. I've got 225 divided by 1500. And I got 15. Okay? And so that's going to be 15%. Okay? So 0.5 is the same as 15%. And so even if I knew right off the bat, okay, he's paying $225 in interest, and I want to divide that by 1500 to get the rate, I can lean on my reference sheet. That's not something that I have to know intuitively. I could still figure that out by doing the algebra. It looks really easy and like, oh my gosh, I did all these steps for nothing. But that's okay. When you're taking that EOC, lean in on that reference sheet. All right, let's do another one. So now let's do exponential growth and decay. So with this one, we see the population of a town is currently 10,150 and is increasing by 2.5% each year. What will the population be in 5 years? And remember, this is the formula that they give us on the reference sheet. Now this is for compound interest, but if we're talking about population, I know that that's exponential. And so I can use this same one to figure out what my population is going to be. So now my population is going to be whatever I started with, because this is still going to be my starting point. Okay. And then 1 plus R, we're not compounding anything within that year, so N is just going to be 1, and then multiplied by that time as the exponent. And so here we go. Our starting point is 10,150 times 1 plus, and then remember 2.5%. We want to write that as a decimal. That's going to be 0.025. If you're not sure, just pop it in the calculator. 2.5 divided by 100. Oops. 2.5 divided by 100. Okay, and that gives us 0.025. And then T, we're talking about what will the population be in 5 years. And so I'm going to put 5 up here. And so as you're doing this, this is something I could type into my entire calculator. They might actually ask you for something that's equivalent. And so you might see something where they put this together. And so when we think about this, 10,150, okay, the 1 means that we're keeping the original population, right? And then we are adding on that 2.5%, so 1.025. So you might see that on an exam. And then we just want to remember that increasing means plus. And so we want to use plus here. If they were talking about decreasing, we would put minus, and so it's going to be less than 1. And in our video about exponential functions, growth and decay, we talked about that, about the number that's being raised to a whatever power. If it's greater than 1, it's going to be growth, and then if it's going to be less than 1, it's going to be decay. And then so we're just going to pop this into our calculator. And so I have 10,150 times parentheses 1.025 close parentheses y to the x 5, and that gives me 11,483. And then if I wanted to round it, or if they asked me to round to, let's say, the nearest tenth, that 9 would change the 7 to an 8. So let's just put 0.8 here. And that would be my population. So that would be a growth problem since it's increasing. All right, let's try another one. So this one says exponential growth and decay. A stock investment is depreciating, so that means it's going to be decreasing. Depreciating is going to be decay at a rate of 3% per year. So anytime I see that percent, I'm automatically going to kind of think, is this exponential growth or decay? Just by looking at the scenario. And it says a rate of 3% per year. If the initial investment was 14,500, how much will it be worth after 7 years? So I'm still going to take what's on my reference sheet. And so let's say my investment, or I'm just going to make this up, in my investment account is going to be whatever I started with, 1 plus the rate, but be careful, my rate is going to be negative here, so just kind of keep that in mind. But this is what I have on my reference sheet. You can write plus or minus there to kind of help you out. Just remember that the rate is 3% and it's going down, so negative 3%, so I can put negative 0.03 for the rate. And that's my starting point A, so 14,500 times 1 minus 0.03, and then my time is 7 years. Okay. And so when I see this written out, if they ask me for an equivalent expression, I might see it as 0.97. And then just remember, as we talked about those exponential growth and decays, if this number here is less than 1, we know it's going to be a decay problem. And then from here, I can pop this into my calculator. 14,500 times point. Let's clear out my calculator. And then y to the x 7, and I get 9,402.9, and then let's make it look more like money. So that 5 would change that 2 to a 3. So 9402 point, and then 93, and then dollars. And now let's get into the problems that our reference sheet is actually made for, which is compound interest. And so for this one, it says Isaiah applies for a loan with an interest rate of 4.2% compounded monthly. So notice that it uses the word compounded. And so it's signaling that we're going to be using compound interest. So you don't really have to sweat whether, oh no, which one do I need to use? Am I using simple interest? Am I using compound interest? On your EOC, it's going to say compounded for compound interest, most likely. So that's not something you have to super worry about. Okay, and then it says compounded monthly. If the loan was $15,000, how much will he pay back after 6 years? So for this one, they're asking how much is he going to pay back, or how much is going to be in that account after all the interest racks up. So we are starting with 15,000. That's our starting point, times 1 plus, and then our rate is 4.2%. And that's going to give us 0.042. In your calculator, just put 4.2% divided by 100, and that's going to give you 0.042. So 0.042 divided by, and then n, remember, is the number of times it's happening in that year. And it says compounded monthly, so that's going to be n. There's 12 months in a year. And then they're asking, okay, so how many times is this going to happen over the entire time period? And so that's going to be 12 times a year for 6 years. And so it makes sense that that would be 72. So that's going to be 1,500 or 15,000, sorry, times. And then for this, when they're asking for equivalent expressions, they might ask you to kind of put this in your calculator. That's the most common. And so 1 plus 0.042 divided by 12 gives us 1.0035. And then that's happening 72 times. And when I put that whole expression into my calculator, I get $19,290.45. All right, let's try another one. So it says Xavier invested $3,000 with an interest rate of 3.1% compounded weekly. How much will his investment be worth in 13 years? And so same thing with this one. We're doing our starting point times 1 plus, and then our 3.1% is going to be the same as 0.031. And then n is the number of times in a year, and it says weekly. And so if you can't remember that there are 52 weeks in a year, that is on the reference sheet in the conversion tables at the top. And so that's going to be 52. And then how many times is this happening over the entire time period? That's going to be 52 times a year for 13 years. And then let's go ahead and put some of this into our calculator. So 1 plus 0.031 divided by our 52 weeks. And that gives us this. And so a lot of times they'll have you kind of round, and so, or we can just type in this entire thing into our calculator. So if we need to, let's go ahead and just do 52 times 13. That gives us 676. And so let's go ahead and put this whole thing into our calculator. And so we've got 3,000 times, open parentheses, 1 plus 0.031 divided by 52, close parentheses, y to the x 676. And now from here, that's a little bit easier to kind of round and go off of. You don't want to do too much rounding leading up to your final answer, just because it might be 1 or 2 decimal places off by the time you reach the end. And then especially if you're taking a computer-based test where you're being asked to actually type in the numbers, you might be just slightly off, but that's enough for your answer to be counted wrong. So you just want to kind of be careful. And so for this one, it's going to be 4,488.38. And then we always want to make that look like money. So just kind of be careful and make sure you're really paying attention if they're asking you to round to a certain number. But if they're talking about money, they normally want 2 decimal places behind the decimal, unless they're asking you to round to the nearest dollar. So just kind of be careful and make sure you're really reading those directions so you're not making silly mistakes. And that concludes our video on simple and compound interest, and also doing growth and decay problems using what we knew about exponential functions with compound interest using our reference sheet. And I'll see you in the next video.